Hello, guys. Okay, so for our second conference Monday, today we are focusing on reflections. Last week we identified our three transformations and the proper vocabulary for them. We then also focused more into translations and describing translations using full and complete sentences. So today we are going to be working with reflections. As part of this video, you are going to be doing a notes paper along with my video and then doing a Desmos video. So it is a little bit more than last conference Monday, so I really need you guys to make sure that you are completing everything you were supposed to. So let's go ahead and look at these notes. Okay, so for these notes, a reflection flips a figure over a line of reflection in order to create a mirror image. So notice this uses two of our informal words to describe a reflection. Each reflected point of the figure should be the same distance from the line of reflection on the opposite side. So this is what I was talking about last week when I discussed being just as far away from the mirror or being just as far away from the center line on a basketball court or the line of scrimmage on a football field. Whatever is on one side, the image has to be the same distance on the other side. So this says highlight and identify the line of reflection in each of these examples. So this is an important part of describing a reflection is we have to make sure we can identify our line of reflection. So I want to go and highlight our line of reflection here. And for this one here, you can see that the line of reflection is in the middle of these two. That is our x-axis for this one. So this is our line of reflection, and it is our x-axis is the line of reflection. For our second one, our line of reflection is always going to be between the two, and that is going to be our y-axis for this one. So one of the really nice things with this unit is almost all of the time, our line of reflection is either going to be the x-axis or the y-axis of a graph. Okay, the next part of our notes here, we have two shapes. We have the pre-image and the image. Again, notice that there's the prime symbols on this one. And it says, Bella thinks that the transformation below represents a translation. Is she correct? Why or why not? So we know a translation from last week just slides a figure over, where the reflection would be to flip it over. So if she just slid these over, if she thinks that this is a translation, it just slid over, the G, H, I, and J are all going to be in the exact same spot. But notice on this one, G prime is over here on the other side of the shape. J prime is here close to the J. So this is actually a reflection because the placement of the labels are on their opposite sides. The labeling has flipped. So we want to say this is actually a reflection because the labels flipped with the shape. I'm running out of space with my camera in the way with the shape. Okay, so this is actually a reflection. So if you have a shape that is normally, this happens mainly with quadrilaterals. Four-sided shapes often kind of get students confused as to what type of transformation it is because if we got rid of the labels, we wouldn't be able to tell which one it is. But the labels is what helps us identify that this is actually a reflection. So this says use the chart to compare and contrast translations and reflections. So some similarities between a translation and a reflection. We can say that the shape doesn't change. The shape doesn't change. We can also note that the size of the shape doesn't change. So for both types of transformations, the shape doesn't change and the size of the shape doesn't change. Our big difference is that the shape might not necessarily be facing the same way. The shape is not facing the same way. And we can also say that the ordered pairs are also flipped. Just like we saw in that last example. Okay, so translations and reflections do have similarities, but they are also very different. And it's more noticeable in some shapes than others. Okay, so this one says, use what you've learned to show where the following points would be after the given reflection. We actually haven't done this yet. I'm doing this with you now, and you'll actually get to see why in the Desmos. So here is our pre-image points A, B, C, D, E. And we're going to talk about what happens if we were to reflect it over the x-axis, like this one up here, and what would happen over the y-axis, like this one over here. So if I have the point 6, 8, so notice both of these points are, or both of these numbers are positive points. Both numbers are positive points. And I reflect it over the x-axis, the shape has now gone down, but it's the same distance away from the x-axis. So that means our x is going to stay the same, and our y value is just going to become its opposite, -8. Where a reflection over the y-axis, when reflecting over the y-axis, it's going to flip to the second quadrant or flip to the left, being the same distance away from the y-axis. So this time the x-coordinate becomes its opposite and the y-coordinate stays the same. So this one would change the x-coordinate to the opposite, and the y-coordinate would stay positive. B, we have -5, 1. So B prime, -5 being our x value, and +1 being our y value would put it into quadrant 2. So reflecting it over the x-axis would put it in quadrant 3, that negative quadrant. So again, reflecting it over the x-axis, the x value stays the same. The y value becomes its opposite. So that +1 would become a -1. The y, reflecting over the y-axis does the opposite. So this point is currently in the second quadrant. Reflecting it over the y-axis would put it in the first quadrant, making it positive. So flipping it over the y-axis, the y value stays the same, the x value changes. So -5 would become its opposite of +5, and +1 stays the same. Okay, our point C, we have 10, -9. So positive in the x and negative in the y value puts it in quadrant 4. Reflecting it over the x-axis, the x value stays the same, so that stays positive 10. And our y value becomes its opposite, so instead of negative 9, it would become positive 9. C prime, if it was to be reflected over the y-axis instead, the y-axis would keep the y value the same and would make the x value opposite. So instead of positive 10, this would become negative 10. And and the negative 9 would just stay the same. Okay. D, we have -4 and -11. That puts it in the third quadrant, that negative quadrant. So -4 being our x value, -11 being our y value. When we're reflecting it over the x-axis, that x value stays the same. -4 will stay the same. The y value will become its opposite. So instead of -11, it will be positive 11. And then a reflection over the y-axis, the y value will stay the same. The x will become the opposite. So instead of -4, it will become positive 4. And that -11 for the y value will stay the same. So go ahead and try E real quickly. What is E prime if it's reflected over the x-axis? What is E prime if reflected over the y-axis? So reflecting it over the x-axis, the x value should stay the same. The y value should become its opposite. So instead of 12, it's going to become -12. Reflecting over the y-axis, the x value is going to become its opposite. So instead of positive 7, it's going to become -7. And the y value will stay the same. So this just stays positive 12. Okay, last section for these notes. Write in your own words what happens to the coordinates in a figure when the following occurs: reflection over the x-axis and reflection over the y-axis. So we're going to actually do this in words and in that algebraic form. So when reflecting over the x-axis, the x value stays the same and the y value becomes its opposite. In that algebraic form that we discussed, x comma y transforms. So this is what we did with translations last week. The original point transforms to the x value is going to stay the same. The y value will become its opposite. So that negative symbol means opposite. And then for reflecting over the y-axis, it's the same thing, just the y value will stay the same while the x becomes the opposite. So when reflecting over the y-axis, the y value stays the same. And the x value becomes its opposite. Algebraically, our original point, x comma y, transforms. That x value becomes its opposite, so negative means opposite, and the y value stays the same. So make sure you have that written down. Okay. So now we are going to look at the Desmos for today. So in this Desmos, This says the pre-image shaded has been reflected to create the image unshaded. Drag the point labels to the corresponding locations on the image. So remember, like I said in the notes, the points would also flip with it. And this shape, it's a lot easier to see because this very tip point is obviously going to be our A prime. And this part here where it kind of goes in, you can see that over here, it goes in, and that point is E. So over here, that would be E prime. Where from A, where it goes out, you can see that it obviously goes out here for B. So this would be B prime. Our line of reflection through the middle, so C should be close to C. And our D being further away from that line of reflection, D prime should also be further away from that line of reflection. And then you can click check my work. Okay, now this one's a little difficult. It says drag the points to create the image of the triangle after a reflection over line K. So this, you are going to have to do your best estimate. Remember, we want each point, if it's about this far from the line of reflection, we want it to be about that far from the line of reflection on the other side. Same with this bottom point. It's a little bit further away from the line of reflection than the first one. So we're going to make it a little bit further from the line of reflection on the other side. That looks like it might be a little bit too far, so I'm just going to bring that in a smidgen. And then our point furthest away, it is all the way over here. Notice I'm keeping it kind of like leveled. So it's still just directly across from that line of reflection. And then I'm going to draw my triangle. Looking at my drawing, it looks like it might be off just a little bit. But once you do it, you'll be able to see what it looks like with all the class. So when I click next, oh, well, hold on. You'll see it on the next one. When I click next here, we're going to do the exact same thing, but this time we have a grid. So we can actually make sure that it's a perfect reflection over that y-axis. So this point here, that's at 3, 5, if I'm reflecting it over the y-axis, it's going to stay at that level of y equals 5. And notice that if it's the x value is 3, I want it to be 3 away on the other side. I can also just count 1, 2, 3. It's going to move 1, 2, 3 on the other side. This bottom point that's at 4, 0, it's going to stay on the x-axis and just flip over the other side of the y. Notice I can count 1, 2, 3, 4 units away from the y-axis. So it's going to go 1, 2, 3, 4 units away on the other side. And then our last one, 7, 3, it is 1, 2, 3, 4, 5, 6, 7 units away from the y-axis. So it's going to go 1, 2, 3, 4, 5, 6, 7 units away on the other side. And now I'm going to draw that triangle. And notice that one looks a lot more accurate than the one I did without the grid. So you can see the difference here. Now, on my screen is a bunch of random examples. On your Desmo screen, you should see the triangles from your classmates and see how well your classmates did with this reflection activity. Hopefully, on this second one, everybody's is perfect. But if anybody made some small mistakes, that's okay. But notice this on the graph, it's more closely correct, or more closely accurate. You can see multiple triangles here, but they're closer together, where on the one without the graph, they're all over the place and not as correct. So the graph was really helpful when we are doing transformations. So this is just like we did in the notes at the bottom half. So it says identify the coordinates of each point after a reflection over the y-axis. So they did the first one for us, 6, 5. So going over 6 and up 5 is that point A. A prime is at -6, +5. So our second point, 2 comma 4, going over 2 and up 4 is our B. So B prime is -2 up 4. We went over -2 and then up to 4. So this point here, -2 comma 4. And then the second point, 8 comma, or sorry, the third point, 8 comma 1. Point C is over 8 and up 1. So C prime on the other side over here is over -8 and up 1. So this point would be -8 comma 1. If I click check my work, you can see that it reflects over perfectly and matches up with the points that I put in. Now, this one confuses a lot of students because this triangle is in 3 different quadrants, but the rule is still the same. If I reflect over the y-axis, my y value stays the same, the x value becomes its opposite. So this 4 comma 5 became -4, the x value became the opposite, and +5, it stayed the same. So for our second point, 6 comma -2, our y value, our x value, 6, has become its opposite. So +6 will become -6. And our y value stays the same. So -2 will just stay -2. And then our point C, -3, -4, that rule still applies. The x value changes, becomes its opposite. So -3 becomes +3. And our y value will stay -4. When I check my work, you can see how when it reflects, the triangles now cross each other. That is okay. That's what happens in a reflection. So I don't want you guys getting caught up if you see a reflection in multiple quadrants. Okay, so it says these points show reflection over the y-axis. Discuss the patterns you see in the pre-image. So this is what we already did. We already know that when reflecting over the y-axis, the y value stays the same, the x value becomes its opposite. So 3 comma 1, that x value becomes its opposite, and the y value stays the same. And then this part here, when you see just the letters, it's asking the same thing as what we did algebraically on the notes. So the x value becomes its opposite. So x would become -x, and y stays the same. Okay, so this doesn't give an example. Like this is like a question about the x-axis, but we don't do all those same examples that we just did, where we did those in the notes already. So it says Amari says that figure A prime, B prime, C prime, D prime is the image of figure A, B, C, D after reflection over the x-axis. Is Amari's claim correct? So look closely at this. Again, we have one of those parallelograms, or well, quadrilaterals. This one is a parallelogram. So you want to pay close attention to the labels. So Amari is saying that this is a reflection over the x-axis, or x-axis being this one. Is Amari correct? Go ahead and answer this question and explain why on your Desmos. Okay, if you said yes, it's good that you noticed that the shape is the exact same distance from the x-axis on each side. However, you want to look at the labels. Is the labels the same distance from the x-axis on both sides? So point D is 2 away from the x-axis. However, point D prime is 1, 2, 3, 4 away from the x-axis. It's B prime that's 2 away. So this is not a reflection. This is a translation down 4 units. So this is a translation down 4 units. I'm going to say I know this because the labels did not flip over the x-axis. The labels are in the same spot on that shape, in their same position. So I can also include that too if I need to, or if that makes more sense for you guys. The labels are, I don't even want to say on the same side. We'll say on the same side of the image as it was in the pre-image. Okay. So slide 9, determine the coordinates of each point after a translation 4 units right and 3 units down. So this is kind of going back to what we did with translations. You guys can do this a couple different ways. You can try and do the actual reflection or the actual translation here. You can move each point 4 units right and 3 units down. Or you can remember what we did with the coordinates. If we go to the right on the x-axis, that means we're going to add to our x value. And if we go down on our y-axis, we're going to subtract from our y value. So I want you guys to try this on your own. I want to see, can you get this on your own without my help? Okay, slide 10, it wants you to complete this table for that translation that you just did. So again, keep in mind the x value, if it's going to the right, is going to go +4, and the y value, if it's going down, is going to go -3. And then I want you guys to write this algebraically like we did last week. So x comma y transforms to, what do we do with the x? X plus what? Y minus what? And I'm already kind of giving you guys a big hint by telling you plus or minus with the right and down. Okay, so lastly, if you know the pre-image coordinates, how can you find the image coordinates for any reflection or translation? Use examples if they help with your thinking. So here are examples of these. So a reflection, we know that whichever axis it reflects across, that is the value that stays the same, where the other value becomes its opposite. And with a translation, we are going to either add or subtract to the x and y values based on which direction it is moving. So go ahead, put that in your own words, or kind of use what I was just describing to help you answer your synthesis. And lastly, here is an example. I want you to tell me what happened here. Did this reflect over the x-axis? Did it reflect over the y-axis? Or did it translate 4 units down? I want you to tell me what happened in this example. And then tell me how you did with the lesson today. Okay, and then our very, very last part, this is going to be the big one that helps you with your homework, because your homework is going to be very similar to this. And this is what we are really focusing on as an 8th grade floor, is working on the describing of the transformation. Sorry, I'm trying to get my camera set up. Using complete sentences. I cannot get this. And I can't make it any higher up, I don't think. Oh, goodness gracious. Okay, that's going to be the best it goes. So this is, number 1 is an example I'm given for us. We have triangle PQR was reflected over the x-axis to form triangle P prime, Q prime, R prime. So notice that we can tell that this was reflected over the x-axis. And the big thing here is that you're telling me what type of transformation it is. This whole paper is going to be reflection. And you're telling me which axis it is being reflected over. What I did not realize is that not all of these problems are the X and Y axis, like I said they were going to be. Dang nabbit, guys. Okay. So with number 2 here, I am looking for the line that's perfectly in the middle of our square JKLM and our square J prime, K prime, L prime, M prime. So I can see L prime is 3 units away from the y-axis here, and L is 3 units away from, sorry, y-axis, from the y-axis here. So my line of reflection here is the y-axis. So my complete sentence is going to be square JKLM was reflected over the y-axis to form triangle. Sorry, not triangle. Square J prime, L prime. Nope, K prime. I'm messing this up. L prime, M prime. When I do this part down here, this J prime, K prime, L prime, M prime, I want to do the same order that I did for the top one. So notice that the sentence structure is the same. I kept the same sentence structure as my example. I just had to change like what type of shape and the labels for the shape and what my line of reflection is. Now, where that becomes difficult is in our problem number 3 here. So notice that this did not reflect over the x-axis or the y-axis. We know that it reflected over a horizontal line, but the horizontal line is not the x-axis. The x-axis is down here. So I want to find a imaginary line that's perfectly in between the two, and I could see that that would be an imaginary line right here that cuts through where my y equals 3. So this line goes through my y-axis at 3. That's going to make this line y equals 3. So I want to say trapezoid because my shape is a trapezoid. Sorry, this camera is not that great. Trapezoid WXYZ was reflected over the line y equals 3 to form trapezoid W prime, X prime, Y prime, Z prime. The same idea with number 4. This time I'm looking for a vertical line, and this one is a smidgen more difficult. So if I was to look at my -2 here, point B, I'm going to choose point B because that one's my closest to my B prime on both sides. So B prime is at 1. So this is 1, 2, 3 units away from -2. And my point B is at -5. So that's 1, 2, 3 from -2. So my imaginary line goes through -2 on the x-axis. Because it goes through the x-axis, this line is called x equals 2. So my complete sentence here will be triangle ABC was reflected over the line x equals 2 to form triangle A prime, B prime, C prime. Okay? And this is what your homework looks like. This is what your homework looks like. I apologize. I did not realize that the line of reflection on this paper and on your homework is not always going to be the X and Y axis. If you struggle with being able to tell what that line is, you can also just say reflected over a horizontal line to form trapezoid W prime, X prime, Y prime, Z prime. Or this one, you could say triangle ABC was reflected over a vertical line to form triangle A prime, B prime, C prime. So again, I apologize. This is my fault. If you struggle identifying the line, you could just tell me a horizontal line or a vertical line. I would strongly suggest working on your homework ahead of time this week, so that way if you get stuck on these two kind of things, you can ask me for help with them. Okay? If you guys have any questions, please let me know, and I'll see you at your conference.